Okay, everybody, here we go again. The idea now is to figure out how to do an impulse response and how to extract the reverb time from that impulse response using eStra. Now I have another model here. I'm going to open up ease 4.3 here, if I can get it done. And I'm going to show you how to do this. This is not quite your model, but it's a lot like it. I'm just going to open a project, and it's called 520 Meeting Room NC1. And we'll just open up this model here. And tell it room edit. And modify data. And here's what this looks like. Let's maximize that. It's basically your room, all right, but it has some sound absorption here, and the ceiling is all lay-in ceiling board. Well, it's going to make a pretty dead room, so we'll change that. Well, we can look right now. We can look at the room data here and see what the RT is. No, it's okay. We can handle this. It looks like about 1 second here, and 8 and 9 say about 1 second at mid frequency. So that's all right. So we'll use this room, and we want to do an impulse response in this room, and the first thing we have to have is a seat. And if I select this floor, which only has 4 vertices, and that's what it takes to do what I want to do, only 4 vertices, I can put a seating area above this face. So here we have area above face, and that puts let's leave it called A1, seating area 1. We'll just say OK, and there it is. It's when not selected, it's green, and this is at a height of 4 feet above the floor where our ears are if we're seated. So now we want to put a seat in here, and if I do a plan view of this, and let's say down here is where my seat wants to go, somewhere over here, where the tip of my wand is, and if I select A1, there it is, at that point I'll put a seat right there. So now I'm going to do right mouse and say seat on area. Okay, it's going to be called listener seat 1. Its viewing angle is 180 degrees, means it's looking this direction, because the minus y-axis is 0 degrees. So we'll say OK. There's our seat. Let's see what this looks like. There's our seat. Excellent. Now we need someone talking in this room, or some kind of a source to do this impulse response. Doesn't have to be someone talking, just a source. And so if we now say go to a side view, and what if we put a source up here someplace, maybe right about here, and up about 5.5 or so feet, 6 feet, something like that. Let's go get a loudspeaker here, and we'll put that loudspeaker here, maybe kind of like the height of a person. Maybe there's 5.6 feet, and maybe out a little bit from the wall, 5.5, something like that. There's our source. And we have to pick we're going to use the loudspeaker as our source here in order to make this impulse response, just as we would in the real world. So the only thing I have is a sphere here, and that'd be okay for getting an impulse response. This is what we'd use if we were in a room with a stage. This is an omnidirectional loudspeaker like a dodecahedron. Well, that's okay. We don't have to go find another loudspeaker. We can just say OK. But, boy, 96.78, that's a lot of energy in this room. We add all that up in third octaves, it'd blow us right out of there. I think we'd rather have something like maybe maybe 75. So if I type 75 in up here in the first row, and then I go say set all to that selection, they'll all be 75. And that's a more reasonable approach here, a reasonable number. And we can say, okay, there we are. There's our source, like it was a dodecahedron, and here's our listener here. And the only thing is, let me look at a plan view again here. This is right on the center line of the room. Let's move it off just a little bit. So let's take this guy and displace him just like we can anything else, like a face or a vertex. And let's move him, say, I don't know, 5 feet in the minus x direction. Say OK. And move him over here. So now there's our loudspeaker S1. And here's our seat, which is, if I want to see the number, I have to turn on, let's see, I want seats here, labels. So there's our seat 1, and here's our loudspeaker S1. I can have that labeled if I like here. Don't have to have it, but I can. Doesn't hurt anything. So now I'm ready to do an impulse response. So let's go back here to this view, kind of nice view. So there we are. And I don't really need the audience area, but I can leave it I can leave it show, let it be seen if we want. That's all right. So now I'm going to go back to my main screen here, and I think I better go back over here. Before I do anything else, I better do an F6 and save all this stuff. Then I can go back to my main ease screen. I'm going to go to Aura here, Room Acoustics, Aura. This is a Room Acoustics module. And what I want is Aura Response 3D in 3 dimensions. So I select that. And I get a rendering of the room, which I don't care at all about. And there's my listening area, my seats right there, can hardly be seen. And so I think I will, I'll just minimize that. Well, let's go back there for just a second. And I think I'm going to turn off the audience area so I can make sure my seat is above the floor. If I do a side view here, I can see that. Yeah, there it is. There's the seat right there. And there we are. So I can just minimize this. Here's the window I want, my Aura response calculation. First I have to pick the loudspeaker. We'll only have one, S1, so I'll say OK. And I want to create a binaural impulse response. And I don't need to do anything else with it except save it to a file. That's it. I'm going to create a response file and a BIR file, binaural impulse response, because I can open that in ISRA. So I'll go to locations, and Walker just says, well, put it anywhere you like, but I'm going to put it on a listener seat. Here's my seat right here. I only have one. That's easy to select. And it says, well, I'm going to call this file when I get it Aura 0001 underscore 1 means seat 1, and it's a response file, RSP. That's fine. And under calculation, I have to decide how many particles or rays I want here. Now typically, to get reverb time, I really don't have to change these. I'll just be fine. I could have a longer impulse response. Sometimes I set it as long as the longest Sabin reverb time, but I really don't have to. This will work fine. And on this computer I can, this is a i7 processor, Core i7, so I can do 8 threads, 8 things at once. I'm not sure about our computers in the labs, but I expect they can do at least 2 things, or at least dual core. And advanced option says what's the cutoff order? 10. We allow 10 bounces, if you will, of each ray. That's fine for reverb time. I really don't need to change any of this. That's good. And my location is alright on seat 1, and my loudspeaker is fine. I'm ready for the simulation. So I'm going to start it right here. It says it takes about 2.8 megabytes of RAM. That's just fine. Say yes. And it's going to do this in about 25 seconds. It will generate this impulse response. So we'll just, it's already post-processing, and it's written a file to projects 40, and under ray tracing it's put aura 1_1 RSP, and our BIR file will be there under auralization. So I just say OK. Now I should have that. I don't need this anymore, and I actually just want to look in the file. I've still got, this is fine, but I really don't need this, but I'll just minimize it for now. What I want to do is find this response file and my BIR file, binaural impulse response, and they're going to be in the ease folder, and that's under public documents. So I'm just going to minimize all of these here. Well, I can get to public documents quickly because I have it right here. But I could also go to Computer and to Documents and Public Documents. This is where Ease 40 data is. Go to Ease 40 data. This is under Projects 40A on my computer, be 40 on yours. And this was called 520 Meeting Room NC1. And here's all my files for this model. And under ray tracing, I have this one guy that I made, that RSP file, but more important, here I have a BIR file. And I can open this up in ISRA. I should be able to, but what I'm going to do is go at this a little differently. I'll say, well, there it is. I know it's there. Everything's lovely. I'm going to I'll just minimize this. I'm going to open up ISRA here. And it'll take a moment to open up. And when it opens up, it says, go to ISRA data here and find your file. Well, that's not where it is. It's in public documents. I can go to Computer again and local disk C. Well, this gets a little messy now, because where I'll find it is under Users, and in my case it'll be public, and public documents, and East 40 data, and projects. Mine's 40A, yours would be 40. And here we are under 520 meeting room RC1, and it's under oralization. And here it is, BIR. Let's open it up. There it is. By jingo, I've got it right here. There's my impulse response. I can show it in, this is linear in pascals here. This is time going this way. And I can look at it as an energy time curve. And now this is dB, and it's showing the decay. And this is at all frequencies. I'm going to go back to impulse response. And if I want the octave band reverb time, I can get it right here, right away. EDT, RT, octaves. And here we are. Now, we remember the definition of T10, T20, T30. T30, for example, is 30 dB of decay multiplied by 2. And that's this black line. Well, it looks pretty smooth here in octaves. If I want to see the results, it's right here. And here's my reverb time, which will be different from the Sabin reverb time because the absorption in this room is not scattered all around the room. It's not a diffuse sound field. This is more realistic, but it's not a whole lot different. It's a little different here, but not a whole lot in this room. But what if we want this in third octaves? I'm going to go back here to View and Calc, and under Calculation here, I'm going to go to Advanced. You see where it says Advanced here. And here we have EDT, RT, third octaves. Click on that. Well, it's going to go up and down more because it's in third octaves, and these combine into an octave, makes it smoother. And again, I can look at results. I can't read that very well, but I can turn the table here like that. And here I have my third octave reverb times. Well, lots of times what I do here is I copy this to a text file. I'd like to save this stuff. So if I go here to File, Send Table to, File. Oh, let me back up here one. Let me cancel this. There's a quicker way. I can take it right to Excel, right to a spreadsheet, which is handy. I can say File, Send File to, I'll just say Clipboard. Okay, good enough. This should be in the clipboard. Now, and I'm using T30 here. This will vary because of the what's happening to the decay with time, but this is where we want to be if we can, if it looks reasonable, and this does. So all I have to do here is I'll just minimize this, and I'm going to open up Excel here. Here's Excel, and maybe I'll put it down about here so I can put a title up here, and I'm just going to say paste. Great. Here's the whole thing pasted into an Excel spreadsheet, and I want the reverb time to put in my problem where it's supposed to go. Well, here it is right here on whatever frequencies you want. You don't have to copy the whole thing. So now you've got all the data, and you can remember what it is. You can say this is what? Reverberation time. Ease. Meeting room model. 520, say, or see, H, say 520 if you like, oh, whatever you want to call this. Put your name in here, and you've got it, and you can save this file and save it as something. So here, if I wanted to save it, I could save it wherever I like on my documents here, or I could put it on the desktop and say, just call this, I think I hit the microphone a couple times there, that'll make some noise. I'm going to say, what'll this be, 520 final, oops, hang on just a second, I get that right. Final project, or whatever you want to call it. Gee, my typing is terrible. And save it. And now it should be on the desktop, and I have that information. So I can close this guy, and I should have, here it is right there. There's my ISRA file. So I think I'm through with all of this now. I think it showed you how to get this. So I'll close it here. And we don't need the E's any longer. And you don't really need this model because your model is the one you want to use, not this sample. It's different, a little different. So I'll just close it here. And I can also close it here and say, gee, that's about it. So I'm going to do, to get out of this recording mode. So hope this helps. And so long for now.